Glad to be here too. I had a false start a couple of years ago. There was a pilot strike and Lufthansa made me stay away from the conference, so that was super fun. Thanks for the intro, because I'm not trying to be the blockchain guy. I'm actually the voice over IP guy that started researching more into blockchain over the last year or so. So I don't have to give so many voice over IP creds up front because that was handled for me. That's nice. I have a couple of hats on, so if you want to talk about mobile networks, building infrastructure, I can do that. Range Networks invented OpenBTS, and I've worked for them for about 6 years now, so if you want to talk about how OpenBTS works or anything like that, I'm available. Also started as a core developer on the decentralized VPN project. I'll talk about that a little bit later with some more context. And well, sponsored content. If you have anything that you'd like help working on, I have a little company that does research and development, so if you need help with any of these types of things, I do that. PR over. Blockchain, right? It's amazing. It's going to solve all of our problems. No, it won't. It's right. Oh, do we get a, okay. See, I didn't even know we were playing a game. I'm going to try and give you enough background where you can make a determination if blockchain is actually this happy unicorn for your specific use case, or if it's full of smoke and makes no sense. So in 30 minutes, that's quite the challenge. This is my challenge, is that everyone on Twitter is snarking about it's a distributed database and it's a piece of junk. That's great. That's how any new technology starts. Remember voice over IP, that thing that didn't succeed and it came out and they were like, oh, they're gonna change the way that telephones are transported. Who cares? It's, it's not TDM anymore, it's packets, that won't change anything. Kind of missing the point about how your infrastructure changes and more people can access and build services and build hardware and technology and use this new open standard. Yeah, the internet, this is a really long quote, but my favorite part is that the entire premise of this guy's article in 1995 was that the internet would fail because there are no salespeople for retail. That is painful. I'm sorry, salespeople. You are very, very, very needed, but maybe not in big box stores. Telephone, telegraph, printing press, you can find quotes about all of these technologies. As soon as they came out, somebody had to come out and say, oh, that's stupid, that's a toy, no one will ever use that. So let's start to detangle this a little bit. Blockchain versus Bitcoin. Blockchain's a technology, Bitcoin is an application. They were invented at the same time in 2008, and Bitcoin actually invented blockchain as a way to accomplish what they tried to build, which was a breakthrough application that let people actually do decentralized cash. This was not possible before because you always had to have a central authority to maintain a record of who had these virtual units of cash. So this is how they solved it. They made something called blockchain, and it creates trust among users algorithmically. The trust is in the protocol. So in between the two users, you can establish trust cryptographically. You have true peer-to-peer payments, and this solves the double spend problem. If you want to research more about that, just type in double spend problem, and you'll see nice little videos on YouTube that are 3 minutes long and explain this. So it's absolutely a breakthrough technology, absolutely a new thing that did not exist before, because you finally had decentralized consensus. That's not something that you can do, not something that you could do before. You always had to have a central authority. So this opens up a new way to think about network applications. And this is maybe a little bit over the top, but it's kind of like inventing email and then going, I wonder if there's anything else we could do with this network. I mean, we can send messages back and forth, so maybe we could send like pictures or video or run our TV channel on it. This is the essential problem that they solved. It's a Byzantine generals problem. Does anybody know this problem or has heard of this problem? It's a classical problem. It's been around for years. So I'm going to very, very quickly try and explain it. You have some generals that are allied in the sense that they want to attack this city, but they can't coordinate. They can't drop into like a conference call and say, so 8 o'clock, right? They can't. They're separated by distance, and it takes a while to communicate. So they have their different plans. Well, one sends a letter to the next. It has the plan of attack. He either agrees or disagrees. They pass the communication around the loop. And by the time it gets back to the first one, he doesn't know if they're going to attack or not, what time they're going to attack, who changed the time. No idea. So how do you solve this problem? How does blockchain actually solve this problem? They still want to attack. They have different times, and they need to coordinate. So the first message is sent. Writes it on his parchment, sends a rider off, a network packet, if you're following the analogy, sends off the rider to the next guy, and we add a rule. So every time we make a message, there's a rule about the creation about that message. You have to always take a fixed amount of time to create the message. Doesn't matter. If it takes you 5 seconds to write your letter, you have to take a fixed amount of time to write the message. So you make the generals like draw a horse at the bottom, like sketch your horse at the bottom. So we make sure that this message takes 3 minutes to make every time we make this message. So he sends it to the next guy. He agrees. Second rule, the message must be unique. You can't just say like, check mark, I agree with the first one. You have to make a whole new message, and it also has to take a fixed amount of time. And you then pass both messages on to the next guy. Oh, sorry. I skipped a little bit here. So he also has to draw a picture of his horse too to fill up the 3 minutes, right? Then you send both of the message on to the next guy. You do not destroy the other one. You don't tamper with it in any way. You send the original message on with your new message. Messages are only appended to previous messages. You can never alter or destroy them. So now the third general has both of the first messages. He can look at them, agree, and say, yep, I'll do the same thing. I'll take another 3, 4, 5 minutes, whatever we have this set amount of time set to make my new message, and I'll send it to the final general. He gets all the messages and says, that's kind of a crap idea. I don't like it. Let's go at 10. So he crumples up the other messages, writes his own message, and he can't fake the other message because there's a rider waiting outside of his tent, and he says, well, the message has to be done in 3 minutes. And you have to sketch your horse, and sketching your horse takes 3 minutes, so you can't sketch 3 horses in 3 minutes. That's too difficult. So it fails the time test. The rider picks up the only message that is complete, and now the first guy knows that General 4 disrupted the plan, because I only have his messages, all the other messages are gone. He would also know if General 2 disrupted the plan too, if the messages didn't match up, the plan didn't match up. So it's kind of a very quick run through of how that solves the problem. In blockchain terminology, a node is the general. Every general represents an instance of a decentralized application. The network is the riders sending messages back and forth. Transactions are actually how you call them on a blockchain network. It's not a message, it's a transaction. It's just messages being sent around, but it's a transaction on the network. Multiple transactions are bundled into a block, and then each block of transactions must be created in a fixed amount of time. So in our analogy, it was every message. In blockchain land, it's actually every block of messages, every chunk of messages in the network. And this is called proof of work. Each block requires significant effort to be created, and that's difficult. And depending on how difficult or how much time you want to spend creating each message, if it's 5 minutes, but you got a guy that really is good at drawing horses, well, then you have to make him like draw 4 horses or more horses, draw more horses. You'd have to take longer time to make your blocks. And this is what mining is, because not every general wants to perform this task. He doesn't want to sit in a tent and draw 25 horses at the end of every one of his messages. And so since that is valuable, the drawing horses aspect of this whole thing, the network stops working if no one's drawing the horses, right? If no one's mining, the whole blockchain network stops working. And so it has value, and that is where people earn money by mining on a blockchain network. They're making the network actually function. So it's rewarded by the network. Blockchain, real head scratcher. It's a sequence of blocks. They're in a chain. They're, sequential, one after the other. And that's also called the public ledger. So every node has a copy of the blockchain. That means everybody has this public record of what has happened, which also means that, every transaction that's ever made. But it also means that everybody knows the truth. Everyone has this consensus. Everyone has global consensus about the state of this network. There is no third party above anybody else coordinating things. The consensus is built into the protocol. So how do you participate in this network if it's completely decentralized and nobody manages your user accounts? How do you create an account? You don't. That's how you do it. You don't do it. They're entirely based on public and private keys. Your public key is like a username on the network, or maybe an address, and the private key is the password. So you have this pair of keys. And I sign messages to you with my private key, and I address messages to your public key. Then everyone validates my messages with my public key, so they know that I sent them. They know that I'm me acting as myself. And that's what creates the trust on the network as far as that level goes, as far as creating user accounts and tying them to a single person, that kind of stuff that usually you would need a higher authority to. So your public key is used to deposit, private key is used to withdraw, or read and write keys. You can think of them that way as well. And everyone has to have a wallet. Who's heard of a wallet? Like a wallet on the Bitcoin network, right? Who thinks it has your Bitcoins in it? No, sorry, it doesn't have your, if you lose your wallet, you didn't lose your Bitcoins. You only lost your keys, which is how you read your coins and are able to transfer them around the network. So this is a misleading term. I think it's kind of crappy. It's just a pair of keys. If anyone has your keys, they're essentially you on the network. They are you on the network. If they have your keys, it's over. It's done. So when does blockchain make sense? Do you need a data store? If you don't, forget it. Are there multiple writers? If you only have one writer, who cares? Do the transactions order actually matter? Also important. Are there any untrusted participants? And if there are, could a trusted third party be used? If there's no trusted third party and you have untrusted participants, you need something that allows consensus. So let's get to telephony. Did I do it? I had my plan. 14 minutes. Blockchain in 14 minutes. That was my goal. So I'm sorry if that was fast. All the slides and everything are going to be up on my site later. Anyway, blockchain and telephony. So digital goods, right? What can we consider digital goods? Maybe also minutes, messages, and megabytes. Those are digital goods anymore. They're just numbers in a database. So intra-carrier is easy. Inter-carrier is not. If I want to send you some of my minutes and we're on a family plan on the same provider, it's easy. They love that kind of stuff and they market around it. But now how do I sell you my minutes from Verizon to Vodafone or from E+ to, I don't know, Euskaltel or whatever, right? You can't really do it. But with blockchain, it has this feature that I can send you something digitally and prove that I don't have it anymore. That's scarcity with digital goods. That was impossible before too, without third party. So another way to think about it is that IP moves information and blockchain moves value because you're creating scarcity out of a digital good. It's kind of interesting. There's a company already doing it. You can share or sell what is left over on your mobile plan. They're worth $95 million according to their coin value and amount of coins in circulation. So not a bad idea, I guess. They let you choose a chunk of minutes or data or whatever and send it to somebody else, or buy somebody a packet of data from their carrier. And it's all operated over a blockchain network. All the carrier has to do to integrate it is to say, yeah, sounds like a good idea, put the hooks into their software to actually manage the minutes and decrement or increment them according to what is being transacted on the blockchain network. So pretty cool. Bubbletone, this is kind of cool too. They're making markets among, wow, that's alliterative, making markets among mobile networks and users, basically at a ICO stage, early stage, but they still have a proof of concept. It's really cool. Their video's pretty sweet, actually. Visiting operators all over the globe put these offers in there and they say 50 megabytes or 500 megabytes for 20 cents or $2 or whatever they want to make for an offer. And then you can browse the offers in an app. You can send coins to this smart contract in the blockchain, and that operator will push a profile through your home operator to your phone that gives you access to that much data or minutes or SMS or whatever. So pretty slick too. All they need to do is integrate the software into their billing platforms, and it's done. There's no need to worry about trusting all the other operators. Pretty cool. Does anyone remember what these RFCs are? Anyone? RFC bingo? Just shout it out with great success about what this RFC was. Oh, it really left a mark, didn't it? It's enum. Yeah, remember enum? Hey, enum was a great idea. You map an E164 number to DNS. Great. Then people can call you for free, and they still use your identifying phone number. Great. Is there any way we could improve it? Kind of always needed a higher authority to record the mappings. So if you didn't have that, it didn't work. If the authority was ever down, the calls don't connect, you can't look up anything. Here's another one. Project Distributed Blockchain Services for Business and Personal Use. Incredibly generic, but one thing that they do is they have something called ENUMER or ENUMER, I don't know, and EMC DNS. So they have decentralized DNS and enum. So you register your E164 to DNS mapping in the service. You automatically verify that you own the phone number by a third-party service. They originate a call to your phone, give you a number, you type in a token to pair it with that mapping to prove that you own the phone. And then, this is the best part, the mappings are stored locally in each participant's copy of the blockchain. So there's no lookup time. It's really fast. It's on your local machine. There's no such thing as downtime because everyone has a copy of all these mappings. Pretty slick. Infrastructure. The world's first decentralized mobile network, 40 million bucks. I'm sorry, I don't get it. I read this thing and I don't know, I don't get it. There's a lot of white papers, and maybe someone can explain it to me. Like, I'd love to talk to someone who's behind this because it's really interesting, but I don't get it, I'm sorry. They're talking about mounting base stations on cars and no consideration for spectrum, and I thought that seems crazy. So I don't, you know, whatever. This is interesting. Read this paper. Blockchain-enabled spectrum access in cognitive radio networks. Negotiating directly among towers for spectrum access based on usage, demand. They can create their own market. They can run an algorithm that, you know, wants to give this many coins for this many slots or this many time slots for this much time, whatever. So market making directly among towers. That's pretty cool. Mobile payments. Is there any room for improvement? Hey, who's heard of M-Pesa, by the way? Yeah. Okay, good. Hopefully somebody. It's gigantic. It's like a sizable chunk of Kenya's GDP, or more than half of the Kenyan GDP is an electronic payment that runs through your mobile, through your handset. So is there any room to improve it? Well, blockchain was literally invented for payments. So probably. And if they would implement something standard, as in some standard blockchain technology, now all the carriers and shops have an open technology to deploy instead of relying on the group behind M-Pesa. And users can move their assets between carriers and countries without needing any explicit permission because it's on the blockchain. They can transfer it out, they can do it to an exchange, they can withdraw it into cash. Somebody's doing this. Maybe you've heard of Ripple. That's a couple extra zeros in the market cap. They're worth $30 billion right now, and 12 of the top 100 banks are participating in the Ripple network. Small names like American Express, BBVA, Unicredit, Santander. Yeah, anyway. This is not done yet, but this could be interesting. Stolen device database. The stolen device database was always kind of theoretical. If you report your device stolen, then when somebody tries to reactivate it on a carrier, they could send a signal. There's a defined signal to send to the phone to actually kill it and shut it off, which is a fun code actually to know in GSM. You just send that to the phone and it stops. Anyway, so the new devices could like generate a token on the first time use and transfer the token to the new user. It's somehow embedded in there something. And if it's stolen, then you could spend the token, which means like burning it. I didn't want to put burn in there, but you could make it evaporate. And then that token's no longer valid. So when somebody tries to sell it or a carrier tries to activate it, they can read that and say, that token has been spent. That is not a valid phone. It's dead. Number portability database 2. Bunch of carriers. They have to, you know, coordinate with each other. I have to kind of jump through these actually. If you get a fresh DID, then you have to pay a deposit, you generate a token, you can transfer the token back and forth, maybe you have to add a fee because you're moving the token around the network. and then you spend it to return the deposit. So this is an idea, maybe. Inter-carrier settlement. This is a big one, actually. Definitely room for improvement. There is no higher authority. There's totally untrusted parties here, and they have to settle billing at the end of a period. They have to go through a clearinghouse. It's very expensive, very manual process. It's kind of just enforced by fear of repercussion. Like if I lie about how many minutes that your user used on my network, well then maybe my users aren't allowed to roam onto that network in the future. Or, you know, it's kind of a fear-based enforcement, I think. There's already a pilot program entering the second year. British Telecom, Telefonica, Telstra, HGC. Pretty cool. They've been happy with it in the first go-around, and so they're expanding it, adding some more carriers. This is what I've been working on since about February. I joined the group. We're doing a decentralized VPN, basically market making for VPN connectivity. It's like Tor, but faster because it's not. That's not the point. Is, you know, anyway, it's faster than Tor. You get a reward for providing connectivity, so there's coins transferred into you if you're providing an outgoing node. Maybe safer than centralized providers, depending on the country and regime you live in, and where they can't just like get all the records suddenly. And this might take some explanation. Maybe talk to me in the hall. Egalitarian mining is basically, we don't want any ASICs or any sort of specialized hardware to ever be able to mine the coin. So anybody who has some extra cycles on their computer can generate coin pretty easily, and then they can spend that to use VPN services. So they're paying for VPN with electricity, basically. So anyway, that goes away if you let specialized hardware run on your network. Current limitations, transactions per second. It's not even in the same league. Visa's 24,000, Ripple's 1,500, it just tails off. Bitcoin is 7 transactions per second. Yuck. Not exactly designed for speed. There's only implicit finality. You only get finality once you get so many blocks past your block. So there's no explicit finality that says this is the absolute truth and global truth. And there is no interoperability between blockchains. You can't transfer things between blockchains without trusting a third party. It's not very usable because it's new tech. Data visibility, you can't really hide the records, right? Or expose the records at will. It's not very granular. And you traded centralized infrastructure for centralized governance. There's only one person making the software maybe, or one group behind the software. So that gets a little sketchy. There's progress on all fronts though. Sharding, transactions per second. That is a pretty good scale, a way to scale. They're working on that. Side chains, basically little tiny like octopus chains that come off of the main chain and then rejoin eventually. State channels, another technology that lets you do, like play a game of chess off the chain, sign all the transactions, load it back onto the chain, and then actually verify all the transactions cryptographically. So you can have all these really fast transactions off the chain and run it back in. Proof of stake, this is a big one. Ethereum is going to move to proof of stake instead of proof of work, which is the generals and the horses in the drawing. And that would give them explicit finality, where you can say, absolutely, this is the global state of the network. Delegated proof of stake is very, very different, but sounds the same. And atomic cross-chain swaps are also in the works, so that will let people trade assets between different blockchains without trusting a third party to hold their assets. And there's even a website that shows the readiness of the swapping. So these are all the chain technologies and all of the abilities to swap between the different chains. So there's it's like, is WebRTC ready yet website for swappability? Pretty slick. Account recovery, you lose your keys, they're gone. But there's tech working on that to regenerate keys off of like a mnemonic. Pretty slick. Pull payments, stuff we're supposed to be able to do with payment technology. You shouldn't be able to have to push all the time. Okay, centralized governments. Want to take a guess what they're going to do to solve the centralized governance? Put it on the blockchain. Yeah, that makes sense though, right? So they're going to be a way to do governance on the blockchain as well. So you can vote out the leaders of a project and get somebody else in there and take away their ability to publish things. Pretty cool. All these things are interlinked. Swaps help proof of stake, so your decentralized exchanges no longer hold a bunch of coin to be able to make influencing decisions on the network. and then proof of stake helps sharding, you have to have explicit finality so that multiple chains can be reliably maintained. So all these things are kind of a big moving mass of technology. Okay, I got 2 minutes. What happens if we do like enter the unicorn land? It's fun to think outside the box because this is what Range Networks did with OpenBTS, actually, small plug. This is what a GSM network looked like before, and this is what it looked like afterward. It's a little more simple. So, you know, maybe there's ways to do these kinds of things at a telecom scale. There wouldn't be any centralized user accounts, you know. KYC, you could do that with reputation service. Market would be completely open to all carriers. You can get your DIDs as you need. Everyone is always roaming, right? The infrastructure is just there, and then you pay for using it. And it depends who markets it to you and which coin you use, whatever deals they have negotiated. So they might just be pipes, but there's no acquisition cost. No one's marketing, no one's doing anything. It's basically all automated. And this is the big one for me anyway. Logical spectrum allocation. It finally makes sense. The towers can finally negotiate with each other and allocate their spectrum in a logical way. So kind of like sharing economy for infra, to throw another buzzword in there, sharing economy. And I like this one, something like bare metal over the top. So all the fun of over-the-top services, but it's running directly on the infrastructure, if you want to think about it in that way, right? You tear down all those crazy technology barriers in between all the carriers, you make them talk to each other at a protocol level, like really, and then you're left with just bare metal. It's very fast, kind of like the presentation, and I'm sorry, but I think it's really important. I think it's really interesting. There's a lot of marketing crap out there. I hope this didn't feel like marketing crap. I hope that it felt like a technical introduction and some context for what you actually can do. Questions probably have to be in the hall because I think I'm a minute over.
Yeah,
so
while we change the speaker, we'll have Miriam preparing and some, you have a question? Ole or not? No. Okay. So questions from audience, leveraging blockchain for telecom. Anyone else doing it?
Oh, sorry.
Right.
Or too many questions, I'm sorry.
Okay, so I have actually a question because actually you can build your own blockchain, right? So how is this like, you know, could you eventually merge some of this in the future, like let's say two companies starts or two projects starts building their own trust relationship with blockchain? It's any way to merge such structure in the future? Let's say now I trust everyone you trust. That's the goal of like the atomic cross-chain swaps. It just means that atomic. Yeah, it's a great word, but it just means that you can replicate that trust channel, that entire history of trust for a certain asset or user or whatever. And you can replicate it onto another chain, provide some anchor into the other chain, and be able to validate things without trusting somebody else to move that information back and forth. Okay. So that's how they're going to try and do it. Yeah. Do you have a question? Or? I will comment. Uh-oh, that's the worst.
As the marketing manager of Kamailio, I've been kind of worried about the business plan we have for Kamailio project. Daniel and I discussed it last week. So in a few weeks, you'll be able to invest in our first Kamailio ICO, and you're going to be filthy rich, or at least some people will be, but you're more than welcome. Yeah, of course, ICOs, everyone. You heard it here first. All right, okay, thanks, Michael, everybody. Thank you so much.